Hello students, good morning, good evening and good night. Depending on which time you are going to observe this lecture. Welcome to the fourth lecture on alcohol, phenol and ether. In this lecture we are going to discuss again a very important topic, that is the properties of the alcohol. So heading of today's lecture is property of alcohol. In the previous lecture we have discussed about the preparation of alcohol, and in this lecture we will discuss both the physical and chemical properties of the alcohol. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. When we are talking about the properties for the alcohol, alcohol is basically composed of two parts. Number one part, that is alkyl group, and another part, that is the hydroxyl group. Mainly the properties of the alcohol chiefly depend on the OH group, and the presence of the alkyl group just going to modify these properties. First, let us understand the physical properties. In physical property, first understand the boiling point. Boiling point, as alcohol is a substance which form the intermolecular hydrogen bonding, and that is why the boiling point of alcohol is much higher than other hydrocarbons of alkyl or alkyl halides. The hydrogen bonding in the alcohol is like this. You can see this is the alcohol molecule, and this is another alcohol molecule, and this is another alcohol molecule. Within this alcohol molecule there is a hydrogen bonding, and due to this hydrogen bonding only, the ethyl alcohol, as for example ethyl alcohol C2H5OH, its boiling point it is around 351 Kelvin, whereas methoxymethane, this is the ether, its boiling point is around 243 Kelvin, whereas propane, that is CH3 CH2 CH3, propane, its boiling point is around 220. So you can observe there is a big gap in the boiling points, and that is due to this fact alcohol make the intermolecular hydrogen bonding, whereas methoxymethane or your propane, they are not going to make this hydrogen bonding. Of course, the molecular weight of both these hydrocarbons, alcohol, methane and your propane, is almost same. It is having the molecular 46, it is having the molecular 46, and it is around 44. So alcohol has the higher boiling point as compared to the other hydrocarbons of alkyl halide. Second thing, when we are talking about the boiling points, it is also the atomic mass which is going to influence. As the atomic mass is increasing, the boiling point is going to be increases. As for example, methyl alcohol has the lower boiling point than ethyl alcohol. Ethyl alcohol is the lower boiling point than the propyl alcohol. But for the isomeric alcohol, isomeric kind of alcohol like in other cases, what we find as we go from this butyl alcohol, normal butyl alcohol, isobutyl alcohol, you will find there is a change in the boiling point. In spite of this fact, they have the same molecular mass. Why it is so? This is due to this fact, normal-butyl alcohol, you can see its structure is like this. It is totally straight chain. Whereas isobutyl alcohol, it is CH3, CH. We have to go to the structure. This is isobutyl. And secondary butyl alcohol is this. And tertiary butyl alcohol will be this. Then the boiling point, you can see that it is having the boiling point 390 Kelvin, whereas this will be at 381 Kelvin. This will be at 371 Kelvin, and this will have 353 Kelvin. So as we go from the normal butyl alcohol to the tertiary butyl alcohol, what we find that boiling point goes on decreasing, and this decreasing is basically due to this fact there is a branching. Here you can see there are two branches of the CH3 molecule, whereas in case of normal butyl alcohol there is no branching, that is a straight chain. So in this case you can observe that boiling point is higher due to this fact that its surface area of the molecule is larger and there is a higher van der Waals force on the action, and this due to this van der Waals force that is in between this higher van der Waals force, that its boiling point is going to be increases as compared to the branches in the same isomeric alcohols. Okay, so you understand the boiling, how the boiling points of the alcohol varies with different structures and different types of things, that is the hydrogen bonding. Next we are going to discuss another thing, that is solubility. Is greater than any other hydrocarbons due to this fact that it prepares the intermolecular hydrogen bonding with water, and that is where the solubility of the alcohol is higher because of this fact. But when the solubility, we are talking about the solubility, when it is having the lower mass, its solubility much more higher. As for example, ethyl alcohol or methyl alcohol, they are very much soluble, they are miscible in the water in all proportions. Due to this fact, they have the lesser molecular mass. As the molecular mass of the alcohol goes on increasing, means is hydrophobic hydrocarbons part that is going to increases, and which is going to lead to the solubility in the leads to the lesser solubility in water because of this non-polar part. But as it is branching is there, this non-polar part, the surface area of the non-polar part will be less, and this will going to increase the solubility. So we understand, as the branching of the alcohol is increasing, there is the increase of the solubility of the alcohol, and as the molecular mass is going to increases, the solubility of the alcohol is going to be decreases due to this fact that there is the non-polar hydrocarbon parts, and this hydrocarbon parts going to influence. This is a hydrophobic in character that it will going to make the less soluble. So we understand the solubility. Solubility is basically that lower, we can write the lower mass, molecular mass of alcohol have higher solubility. So these two things that we discuss on the physical properties of the alcohol. Now we are going to discuss the chemical property of the alcohol. Chemical property. Alcohol is a versatile organic compound. It acts as both nucleophile and electrophile. When it acts as a nucleophile, at that time there is a breaking of the OH bond. As for example, this is alcohol. This alcohol when react with acts as a nucleophile, and when it will be react with this electrophile, that is it may be a carbocation. When this will react with this, so at that time this structure will be like this. This oxygen atom will be joined to this positively charged carbon, and at that time the lone pair electron in the oxygen will be taken up by this carbon, and it will make a bond with this, and you will find this structure, intermediate structure. When there is a positive charge has been grown in the oxygen atom, at that time it will want to compensate. How do it compensate? By taking the electrons from this bond pair. So it will take this electron from here. So ultimately in this process you can see there is a breaking of the OH bond. So this product will be created here, you can see, and there is a formation of the H plus. So in this process there is a breaking of the OH bond. Another thing, at that time we can write it is act as a nucleophile. Nucleophile. It is act as a nucleophile. When it is act as a electrophile, at that time first the alcohol has to be protonated. Suppose this is a alcohol, and this alcohol has been protonated, means it will have H plus ion and it will be CH2OH2 plus, and it is now acts as a electrophile. So this will going to, suppose Br minus is a nucleophile and it will attack this electrophile. Now alcohol acts as an electrophile, so we can write CH2R and OH2 plus. So at that time this Br minus will attack this carbon atom, and this H2O will be a leaving group, and at that time you can observe there is a breaking of the CO, carbon oxygen bond, and alkyl halides has been prepared with this process. You can observe this. Br will be, this is Br, CH2R and H2. So you can write this H2R H2O Br. Alkyl halides has been produced in this fashion. So in this case you can observe there is the breaking of the CO bond, and in this case when it is electronucleophile, it is having, you can observe it is the breaking of the OH bond. So the reaction in the alcohol has been divided into two parts. One, the reaction which involves the breaking of the CO bond, and another the breaking of the OH bond. And another case we also observed in case of oxidation, that there is a breaking of the two bonds simultaneously, and there is a creation of the double bond. So we understand how with the reactions how it happens. Breaking of OH bond. In this case, the property that we are due to the breaking of the OH bond, the alcohol will find to have the acidic property of alcohol. Alcohol is a very weak acid and its pK value is around 15 and it is weaker than H2. The acidity of the alcohol is basically the polarity of the OH bond. Higher the polarity, higher would be acidity of the alcohol. As for example, so we can write the polarity of the OH bond is the basis of the acid property of the alcohol, and that is the cleavage that relates to the cleavage of the OH bond. So we can write the acid alcohol is the weak acid as compared to the water. So this acid property is basically depends on the polarity of OH bond, depends on the number of alkyl group that is joined in this alcohol. As for example, in the 1 degree alcohol, we can observe there is only one alkyl group present. For the 2 degree, you will find with the 2 alkyl group. In the 3 degree, there are 3 alkyl group. As for example, you can observe that is ethyl alcohol. Suppose in the ethyl alcohol, you can observe there is only one alkyl group present in this. So this is the 1 degree alcohol and its acidity is much more higher than the 2 degree alcohol, that is this alcohol is a 2 degree alcohol. So in this case you will find that is this. That is, what is the name of it? It is the isopropyl alcohol. And third, that is the butyl alcohol, that is tertiary butyl alcohol. As for example, this CH3OH. This is tertiary butyl alcohol. It is a 3 degree alcohol. So you can observe this ethyl alcohol has the highest acid property than this alcohol 2 degree alcohol and then this 3 degree alcohol. Due to this fact, the CH3 group has the tendency of releasing the electron. It has the strong plus I effect. Whereas in case of this, there is a 2 CH3 group, so it will have much more stronger influence. And here it will be 3 CH3 group and it will release much more electron, and around the carbon there is the higher density of electrons you will find. In case of ethyl alcohol, this density of electron less and here it is higher and it is higher. That is why the bond polarity of the OH bond polarity we will find it will be higher in case of 1 degree and followed by this. So this is the acid property, and from this acid property one very important reaction you can see when it will act with the active metals, the reaction with the active metals. Reaction with that active metal means sodium, potassium, magnesium, aluminum. All those are active metals with so here with the sodium it will produce the sodium alkoxide and there is a liberation of the hydrogen gas. This proves the acid property of the alcohol, and the reaction, the activity of the alcohol is 1 degree alcohol have the higher activity, higher active towards this sodium, and then followed by second degree and followed by third degree, because as the acidity goes on increasing, their activity also goes on increasing. Okay, so this is a reaction with the active metals, and this proves the acid property of the alcohol. The cleavage reactions which involve the cleavage, breaking of the OH bond. Second reaction, the reaction with the acid chloride and acid anhydride. Acid chloride and acid anhydride, and this reaction is called the acylation reaction. So here acid chloride, the general formula I have taken RCOCl plus R-OH. The alkyl group in the alcohol and alkyl group in the acid chloride is taken defined. So this reaction product will be this. Here you have to take in the small amount of pyridine. Pyridine is basically base. It will going to react with the HCl, and the reaction is basically a reversible reaction. To make this reverse reaction in the unidirectional, the pyridine is used, and pyridine will react with the HCl, and the reaction, the HCl will be removed in this process. So here you can see that acid chloride will react with the alcohol. It will going to produce the ester. It will going to produce the ester, and here HCl is produced. Second, with the reaction with acid anhydride. Reaction with acid anhydride, we will find here also you can see the reaction is ester is produced, and along this the carboxylic acid is also produced. This is the ester and this is carboxylic acid. Here also we have to use the pyridine. And when this reaction is involved the acetyl chloride, when it is involved the acetyl chloride or acid anhydride, at that time we will call this reaction as acetylation. We will call this reaction as acetylation. Acetylation is basically the incorporation of the CH3CO group in alcohol. Incorporation of the CH3CO group in the alcohol, this is called the acetylation. Next, another very important reaction that we are going to discuss, that is the esterification. In this esterification reaction, the acid carboxylic acid is reacted with the alcohol. This is carboxylic acid is reacted with the alcohol, and it will going to produce ester and with H2O. And this reaction also is the reversible reaction. To make this reaction unidirectional towards this production of the ester, you have to remove this H2O, and for that you can use the concentrated sulfuric acid, concentrated H2SO4, or you can use dry HCl. Okay, and this reaction, that is the rate of this reaction, depends on the alkyl group, of this depends on the alkyl group of acid, carboxylic acid or alcohol. As the alkyl group is bulkier, larger alkyl group, at that time due to the steric hindrance the esterification reaction rate will be lower. So you can see the CH3OH have the better rate, reaction rate, esterification rate compared to C2H5OH. Then you can see CH3 whole 2 CHOH and CH3. This is tertiary alcohol. This is 1 degree alcohol, this is 1 degree alcohol, that is 2 degree alcohol, and that is 3 degree alcohol. So rate of reaction you can see is decreasing as the alkyl portions, alkyl group portion is much bulkier. And this also you can see in case of alkyl group in present in the carboxylic acid also. You can see that suppose the formic acid, in the formic acid there is no alkyl group. This is the formic acid, it is no alkyl group. Its reaction is greater than the acetic acid. Its reaction group is better than this acid. And this reaction is greater than this acid. Okay, so we can understand the esterification and how the esterification is going to influence by the presence of the different type of alkyl group in the alcohols. Now we are going to understand another, that is the reaction with the Grignard reagents. Acid chloride, third one is esterification. That is the fourth reaction, that is reaction with methyl Grignard reagent. Grignard reagent. Grignard reagent is, suppose this is a CH3MgX. This is a Grignard reagent. And when it is react with this alcohol, it will produce the alkane. And the byproduct will be this. So what we will do, we will put here R. So in this case the byproduct will be MgOR dash into X. So you can observe that alkyl group that which is present in the Grignard reagents, the alkane will be as per this alkyl group. But here for the in the alcohol, this will create the byproduct, and this is a very important reactions. Okay, so all these four reactions that we have discussed, here you can find there is a breaking of the OH bond. Now we are going to discuss another reaction, that is the type 2 reaction, where there is a breaking of the COH bond. Breaking of the COH bond. In this case, the reaction type, that first reaction that we are going to discuss, the reaction with the alkyl, reaction with halogen acid. Reaction with halogen acid. Suppose halogen acid is HX. X can be here the chlorine, bromine and iodine. So reaction will be like this. ROH, this is alcohol, plus RX HX, that will be produce the alkyl halides and it will produce the H2O. In this case, you have to use the anhydrous Zn Cl2. Anhydrous Cl2, again it will remove this H2O. So in this case, we have found that there is the you can see there is a CO bond has been break here, and there is a production of the alkyl halide. Production of the alkyl halide. Another reaction where you can observe this cleavage of the CO bond, that is reaction with phosphorus halide. Reaction with phosphorus halide, and the reaction is ROH plus PCl5, phosphorus pentachloride, and this reaction will be RCl plus POCl3 plus HCl. ROH plus PX3. In this case also you can find RX alkyl halide and H3 PO3, and you will get 3 here and 3 here. This is balanced. So all these reactions you can find there is a cleavage of the CO bond. And another reaction, that is the reaction with the thionyl chloride. Reaction. So all this reaction you can see there is the cleavage of this bond. Now we are going to discuss another very important reaction, that is the dehydration reaction. In the dehydration reaction, what we find that there is a elimination of the H2. Suppose this is a alcohol, it is a OH group and there is a CH group and this is alcohol. In this reaction what we find, H2 has been expelled from this with using the proper reagents, and it will there will be the formation of the double bond. Both these bond has been taken, and that will be in presence of the protic acid, like H3PO4 or H2SO4. When we react, so now we are discussing the dehydration reaction. In the dehydration reaction that we have discussed, that when the ethyl alcohol in presence of concentrated H2SO4 with 444 Kelvin temperature, it will going to produce the ethane. When the CH3CH2OH, two molecules will be taken and the temperature is less than this, and this is concentrated H2SO4, which is in little amount of H2SO4 is required for this reaction, and at that time you will see the production of the diethyl ether. Next reaction we are going to discuss, there is 7 number reaction, that is the oxidation reaction. Oxidation reaction is occurred in presence of different type of reagents, that is neutral or acidic or alkaline KN4, or you can use the acidic K2SO4, or you can use the PCC, that is the and a type of reagent which is used to oxidize the alcohol. When the alcohol is oxidized, what it really happens, let us understand. This is the alcohol, suppose. This is the alcohol. When it is going to oxidized, what is going to happen, let us understand. This bond, this CH bond will be break, and this OH bond is going to be break. So you can observe there is the elimination of a hydrogen molecule, and that is why it is also called the dehydrogenation process. Oxidation is also called the dehydrogenation process. And when these two bonds has been broken, that you can easily able to understand that this has been converted into a double bond. So here that you can see, when we oxidize the alcohol, it will going to produce the aldehyde or it will produce the ketone, depending on the oxidizing agent you are using. Suppose it is you are using the 1 degree alcohol, suppose 1 degree alcohol. In this case you can see this is the 1 degree alcohol, right? Because in the 1 degree alcohol, the OH group will be attached to that carbon atom which is attached to the another one alkyl group. That is, one alkyl group is here. So when it is going to reduce, it will going to produce the RCHO. That is the aldehyde. When it is 2 degree alcohol, that you can see that here you can observe that is the 2 alkyl group, and OH group is attached to this carbon atom, and when it is being oxidized, at that time this hydrogen atom will be removed, this hydrogen atom will be removed, so it will going to create this. When it is 3 degree, at that time this normally there is a drastic condition is required, but if you provide the drastic condition, at that time it will going to produce the ketone. So we understand the oxidation reaction, that how it's going to happen, and further oxidation of this aldehyde that we are going to produce the carboxylic acid. Okay, and that is all for today's lecture. In this lecture, we have discussed about different types of reaction, chemical reactions has been conducted with the alcohol, and as well as also we have discussed the physical properties of the alcohol. If you have any doubts, you can comment in the comment section. If you like this video, you can share to your friends. Thank you very much for watching.